So now that we have the basic idea behind an index and how they can help, let's look at actually using them in a real SQL database. So how can we create an index on a column that we want to have one, and how do we pick which columns should have them? Part of that decision is actually made for us. It turns out every table has an index on its primary key, and this is called the primary index. It's going to be there whether you want it or not, and it just has to be due to the way that the engine processes queries. It needs it to be there. So if you're filtering based on the primary index, then or on the primary key, then it's already going to be fast since there's an index on that key. If you want an index on another column, it's called a secondary index, and you get to choose which column or columns have them. Some database engines also let you choose what kind of index it is. So that means what kind of data structure implements the index under the hood. And that has implications for like how it minimizes disk access and performance implications. So to create a secondary index, we can just do the create index command. We can optionally give the index a name, and then so create index on what table we want to create it on, and then what column or columns we want to create it on in parentheses. So it's actually a column list. I've only been talking about single column indexes so far, but turns out you can actually make multi-column indexes, and we'll see that in a minute. But first, how do we pick? How do we decide which columns should have an index? And let's focus on just single columns for now. First of all, don't just put an index on every column, thinking that, well, you're not sure what kind of queries you might want to do, but they might be useful someday. So just put an index on everything. They're not free, though, so you shouldn't do that. Every time you add or delete or modify something in the table, the indexes have to be updated as well. So the more indexes you have, the more costly every modification to the main table is going to be. And they take up a little bit of disk space. So instead, you should think about the common kinds of queries you're going to be doing. What column are you filtering on? And how will joins indirectly filter based on columns? So if you do a natural join, that's kind of an implied filter where you're comparing one column in one table to a column in another table. So even if it's not a direct where clause on some column, you have to think about how joins might affect it. And there's no need for the indexed column to be unique. That's important. It doesn't have to be a key. So like I mentioned at the very beginning of this lecture, we can put an index on, for example, the GPA column in a students table. Even though lots of students have identical GPAs, that's not a problem. We can still index that column. To get good at deciding where to put indexes, which columns in which tables, we just need to practice more. So let's look at an example using a more intricate database. This is just the libraries database we've been using all semester. So the first question we need to ask is, what kinds of queries are going to be common? So let's say we know that one of the most common queries is find all the books that are checked out by a certain patron. And we know only the patron's name, not their card number. And we'll just stop at the checked out table to make this example a little easier. So all we need to know is the serial numbers of the books. So here is the SQL equivalent of this query. And so what kinds of indexes would we want to add in order to make this query fast? And we already know that we have an index on patrons.cardnum and on checkedout.serial because those are the primary keys. So we know that those columns already have an index automatically. So you may not need to add any indexes. Maybe those ones will do it. But let's think about it. So normally I would have you work on this example live in class, and it is just important to practice this stuff. So you should pause the video and actually take a minute to work this out. It'll be good practice for quizzes and exams. So go ahead and pause. Okay, so let's just work through this. We know that we are at least filtering on name, on patron's name. We're definitely going to look for a certain patron with a certain name, so we will want an index on that column. That'll let us take, whatever this string is and quickly find the row corresponding to that patron. And then there's another implied filter here because of this natural join. So natural join is hiding. What it really looks like is checked out join patrons where checkedout.cardNum equals patrons.cardNum. So since the query, though, is going to start by searching for the patron's name, in order to avoid doing the full natural join, it'll filter down first. So let's say it's Joe. We find Joe, so we have his cardnum. We've got an index on patron's cardnum, but does that really help us here? No. We need to take this cardnum and do a lookup in that table. And that table does not already have an index on cardnum. So we would also want to add an index on checkedout.cardnum. So the query will start by using the name index to quickly find the patron. It'll take that cardnum and then use the checkedout.cardnum index to quickly find the book. And then we can just select out the serial numbers. So those are the two indexes that we would need to create to make this query fast. Now, the examples we've done so far have been filters on a single column, so a single where clause or a natural join on a single column. Let's look at a slightly more complex filter. So here's a classes table, and I want to filter where department is CS and num is 1030. So there's an and clause in there, meaning there are going to be two columns involved in the filter. So what indexes could I use to make this query fast? Well, you could try putting an index on department, and that would let you quickly find all of the CS classes, but then you'd still have to do a linear scan through all of those to find the ones that match the number 1030. So you don't know what order they are in within there. What if you put an index on class number? Well, it would let you quickly find all of the 1030s, but there are more than one of them. And there might be lots of them, and then you would still need to go through and look at all of those results to find the one that also is CS. So when there are two columns involved in a filter condition, this is where we can use a complex index involving multiple columns. So we can just put an index on both of those columns. And the way it works, the way we specify it, is we just put the columns into, when creating the index, we just say I want one on department and num. So this is creating a single index. It's not two indexes. It's not one on department and one on num. It's a compound index on both. So how does that work? How does it actually build an index on two things? Well, what it does is it just appends them together. So here is the key for one of the rows in this index. It's just the string CS and then the string 1030 appended to it. So since one of them was a string, it'll take the other column and convert it to a string and just concatenate them together. And then when I want to search using this index, if the system knows that I'm doing an AND condition, it will automatically, and it knows about this index, it will automatically just append the department to the number that I'm looking for in that AND clause and create a key. So if I'm looking for CS and 1030, it'll just create the key CS 1030 and then go look for that in that index. And it'll just do a binary search as usual, and it'll quickly find it, and then it'll be able to follow the pointer over to the full row in the full table. So will this index, let's say I do have this index on department and num, will this index work on a simpler filter where instead of department and number, I'm just filtering by department? So let's say I wanted to do maybe sometimes both of those different searches. Sometimes I want the and, sometimes I just want department. Will this compound index help me search just by department? And turns out, yes, it actually can. All it has to do is look at the first two characters of that key. Since I'm searching for CS, and it knows that the department is the beginning of the compound key, it can just look for the first two characters and quickly find all of the CS classes. So that's pretty cool. I can have one index that supports two different kinds of queries. Now let's look at the other side of it, though. What if I just wanted to search by num? So instead of just department or both of them together, just num. Will this compound index help me search by class num? So maybe we could try kind of the same trick where we just look at the last four characters. And so we would look at, these characters. But this index is not ordered on class number. It's only ordered secondarily on class number. So the classes within a department are ordered relative to each other. But if I'm just looking for all 1030 classes, here's one and here's one. They're not next to each other, and so that they're not actually sorted by class. It's sorted first by department and secondarily by class. So this key lets us search for department, since department is first in the index. It lets us search for department and num, but it does not let us search just by num. So there is a difference between this index with department comma num versus if I made the index with num comma department. That index would let me search by num. It would let me search by num and department, but it would not let me search by department. So the order of the columns in a compound index is very important. Another way to think of a multi-column index is it's like sorting with a tiebreaker. So you sort primarily based on the first column, and then any ties within that first column are decided by sorting based on the second column. So it's only going to sort the second column within the groups of ties. So you get these clusters of subgroups where that's all of the CS classes. Within it, all of the numbers are sorted. But globally, these numbers are not sorted relative to each other. You could have classes numbered 1030 scattered all throughout this table. So let's do another example, just for practice. The common queries we want, just on the library titles table, the common queries we want are find a book by author, and another query equally common is find a book by title and author. Okay, so we know that ISBN is the primary key. That's obviously not going to help. ISBN is not involved in either of these queries. But what index or indexes could we use to make these queries fast? And if possible, we want to use as few indexes as possible if we can do it with just one. So take a minute, pause, and work this out. Okay, let's think about this. So we want to be able to find a book just by author alone. So an index on just that column would certainly help with that query. But we also want to be able to find a book by title and author. So the and clause there would, we would need a compound query to make that work. So can we use the compound query to also search just by author? And yes, as long as we pick the order correctly. This compound query, author, comma title, that will let us search by author and title, and it wouldn't matter which order for the and clause. But if we want to be able to search just by author, author has to be first. So this single index will efficiently support both of those queries. This index, the other way around, would not efficiently support both of these queries. It would equally efficiently support just the second query, because the order of the which column is on which side of the and doesn't matter. Where it matters is if you want to use this query, this index, for another query that's using only a single column. So one final example. What if we replace the and condition with or? So it's the same table, but we want to look for a book with a certain title or with a certain author. So we don't care about the two combined anymore. We just want one or the other. The primary index of ISBN is still obviously not going to help. It's not involved in this query. So what index or indexes would help make this query faster? And turns out it's quite a bit different from AND, just due to the logic between those two different conditions. So think about this for a minute and pause it if you want. Turns out what we need is just two indexes, one on each column. So the reason for that is if we don't find a book with the right title, then we need to go and just look for any book with the right author. Or if we did it the other way around, we could start with author, and if we don't find it, we would need to go and look for any book with the right title. So using these two indexes, let's say we're searching for title Dune or author X. We can use the title index to quickly look through the titles column for Dune. We will find it, and we're done. We get lucky, and we can actually just short circuit the OR condition. It doesn't matter what the author is. Let's say, though, we're looking for a non-existent title or author maybe Seuss. So we can use the title index to look for title X. We don't find it, so we have to evaluate the other side of the OR. And then that's just, well, look through all of the authors to find an author named Seuss. So an index on author can help us quickly do that. We sometimes can get lucky and short circuit, and sometimes not, but either way, we will want an index on both columns. So you might be wondering, why can't we use a compound index to solve this query like we did with an AND? So let's just try it. What if the index was title, comma, author? Instead of two indexes, we make one compound index. So let's do this again, where maybe we're looking for Dune or author of X. Okay, so this compound index will let us quickly search for a title of Dune. So we get lucky and we find it, and we can short circuit and we're done. But let's say we were looking for the title that doesn't exist, that won't be found, or an author of Seuss. So we have to look for X in the titles table. This index will let us quickly discover that there is no X in the titles table, but then we would have to go and search for an author. This index will not let us quickly search for an author. So maybe sometimes we get lucky. If the title is found, this index will help. If the title is not found, then we have to evaluate the OR condition and just look for an author. And kind of the critical difference between OR and AND is that we don't care about how these two things are coupled. We don't care how they pair up within each row. We're just looking for something from one column or something from another column. It doesn't matter how they match. So there's a big difference between AND and OR in terms of what indexes will help search those queries. So just to summarize the rules on what indexes will help with what kinds of conditions. First of all, in a multi-column index, the column order matters very much. So these two indexes here are not the same. They will both help with AND conditions on A and B equally. They support AND equally well. But the one on the left will also support conditions on just A, and the one on the right will also support conditions on just B. A multi-column index AB is also not the same thing as two single-column indexes, index on A and index on B. They will support different kinds of queries. The two separate indexes will not really help with an AND condition. They will help a lot with an OR condition. The reason they won't help with an AND condition is because you need both things to be true. So you could, all this is going to do is let you quickly search for something in column A, and it'll let you quickly search for something in column B. It won't let you quickly search for something where the two are combined in both. It'll help a little bit because you could narrow down the A's. Say you're looking for where A equals 5 and B equals 10. So you could quickly narrow down all of the A columns where they equal 5, but then you'd still have to look through all of those 5s, if there are multiple of them, to find the one with the corresponding B of 10. Whereas the compound index just automatically encodes immediately looking for the two of them at the same time. So in a multi-column index on A and B is good for searching by both columns with AND. It's good for searching by just A. It is bad for searching by B because of the column order. Two separate indexes on A and B is the best option for searching by both columns with an OR condition. Sometimes you'll get lucky and just have to search through A. Sometimes you'll have to also search through B. But both of the searches will be fast if you have an index on both. It is bad for searching by both columns with an AND condition. It is good for searching just by A, obviously, because they're an index on A, and it's good for searching just by B. So to wrap this up, and if you want to try this out on your own, so we already talked about how to create an index on a column or columns in a certain table. We can also delete an index if we decide we don't need it, and we can also see what indexes there are with show index from table.